Okay.
Hello, my name is Kaz O. I'll be doing this organic chemistry problem on tape. So, alright, first thing I noticed about this is that where the lone pair is, and that is on the sulfur. So I look over on this molecule and say, where is a hydrogen or any other molecule that has a dipole or electronegativity difference that could bind to that sulfur, because that sulfur really is reactive with another positive atom. So just to draw out the reaction that takes place, the sulfur would bind with one of the hydrogens and it would deprotonate, and then the bond that keeps one of the hydrogens would go on the nitrogen, making it a negative charge. So, so obviously the nitrogen would have a partial negative and the hydrogen will have a partial positive, as shown here. So what that produces is Cl, and then we have a pentagon. Sorry, the drawings are pretty bad. And then SH right here. And then add that with fluorine. Pentagon. Alright, just like that. Yep. So then from this I go through ARIO. And how I do it is that I look at the negative charges that are on both sides and then compare those two. So, so we will be comparing this molecule right here with the sulfur minus, and then this molecule right here with the nitrogen minus. So how I look at this is go through the atoms. So obviously nitrogen and sulfur are different atoms. So it basically comes down to which can delocalize a charge better. Since sulfur is lower on the periodic scale, okay, it's lower on the periodic scale, so it means it has more room to delocalize its negative charge. Therefore, we're going to say that sulfur is going to be more stable of an atom, of a molecule, and thus it's going to be weaker. And we already know that this is a base, so we're going to say that this is a weak base. From there on, we know that weak bases produce strong acids, strong conjugate acids. So we're just going to say this is a strong conjugate acid. And since this is a weak, this is more unstable than the sulfur. This would be a strong base, strong conjugate base, and this would be a strong acid because strong acids create. This would be a weak acid that creates a strong base. Sorry. Okay. And from that, I think that answers all the questions. So I labeled the acids and bases. I drew the curved arrows showing where the electrons would go and the electron movement, per se. I labeled the conjugate bases and conjugate acids. I ID'd the strong acid, weak acid, strong base, and weak base. And then explained my thought process through ARIO. So maybe I should draw out ARIO and just say it's atom, resonance, I think it's induction, yeah, there you go, and orbital that I'm using. So obviously I use this one because it's ranked in order of like importance. So atom would be like the nitrogen versus a sulfur, and that's how it shows which one is more stable, and thus which one would have a weaker or stronger acid or conjugate base. And then predicting the equilibrium position. Since we have weak acids and weak bases here, that's going to be more stable and it's going to have a higher pKa value. And we know that in reactions, higher pKa values are favored. So this reaction would have an equilibrium that favors the reactants. So it would be like so. And then which two species will be present in the highest concentration at equilibrium? This species and this species will be the highest concentration at equilibrium. That is all that I have for this problem. Thank you.